So hi folks, I hope you have watched my previous video trapping rainwater problem 1, and now in this video we will be solving trapping rainwater 2, which is the Leetcode daily challenge of 3rd of October. And let's directly jump into the problem. So as I have explained in the previous problem that was like 2D version of trapping rainwater, this is the 3D version of trapping rainwater. And here we have given an m cross n matrix with height map representing the height of each unit cell in a 2D elevation map. Return the volume of the water it can trap after raining. So they have given two examples. Let's look at the constraints here first. M comma n maximum of 200 comma 200 matrix. Okay, so it's like 2 into, if I go 2 into 10 raised to power 2, which like square of n like 4 into 10 to power 4. Can I do in n cube solution? 6, 8 into 10 to power 8, 6, sorry. If it is n cube, okay, so we can go n squared till n cube, like square to cube type of solution. No worries in that. That's the constraint telling us. Obviously we will be solving in a beta time complexity or beta space complexity way. What's the optimal approach? We will be going via that. So to understand this example, heat map of this, actually I am also reading this question first time. The trapping rainwater 1 I have already solved previously, so it was like I know the solution, I know the intuitions behind it. But for this you can check, I haven't do any submissions, so this is a fairly new problem for me as well. So I am also thinking out loud with you, and to gain anything like, okay, so let's understand with a pen here. So we have a heat map, okay, and we have here like 3 of them. So 3 cross 2 3 4 5 6, 3 cross 6 ka we have a matrix of 3 cross 6, 3 cross 6, okay. And in this illustration we can see that it's like 6 comma 3 or 3 comma 6. Let me just get this. Now it's 6 comma 3, okay. So instead of, okay, so how much water is trapped here? 4 units of water is trapped here. After the rain, water will be trapped in the blocks. We have 2 small ponds, 1 and 3 units trapped. So somewhere we have 1 unit, on somewhere we have like 3 units trapped. Total volume of water trapped is 4. Okay, great. So how it's going, like this 1 4, okay. So this first array which we are seeing here will be the last one, this last one. So this is 1, then 4, then 3 unit of blocks here, then 1 unit here in deep, then 3 unit here, and then 2 units at the end, 3 units behind this 4 1. So we can't see it. In the second one we have 3 unit of blocks, then 2, so we can trap 1 unit of water here, I think. Then 1, we can trap 2 unit of water here, I think. Then here 3 units here, then again we have 2 units of height, so we can trap 1 unit of water here, and then 4, and that's the end. This is the 2 3 3 2 3 1, yeah. So that's how this laid out, okay. For better explanation perspective, let's create matrix, okay, and let's visualize from the matrix perspective if we can solve by that. So it's like 1 4 3 1 3 2. Okay, I think we can. So now second is 3 2 1 3 to 4, 3 2 and 4. This is the also, and last one is 2 3 3 2 3 1. Order doesn't matter, guys. Like I am doing here like first row, second row, and third. First row, first vector of vector. So first element, second element, third element. I am making these as columns. You can make it as rows. Doesn't matter much, and you can rotate this whole structure. So because it's a length, and we do not have anything ordering type of problem here, so that's not the case here. Okay, let's understand this. So first of all, the first thing I am like thinking about, that we can't trap any water in the boundary. This is the boundary, right? This is the boundary. Anything we keep in the boundary will be split out. Okay, it will be split. We can't trap anything in boundary. We have to trap in between this. Okay, got it. So first observation, no boundary. Okay, and what observation we can make? How much water we can trap at one cell. So let's say this is the cell number 2. Okay, how much water can we can trap? Like its maximum height here is 4, the above height is 3, the 3, and there is 1. Okay, so there is 4 heights. We can trap only how much water? 3 unit of water here, and we have to check for this how much here. If there is nothing in here, so we can trap only 1 unit of water here, and the water will be split. If there is something like 3, then this water will be trapped. So we have to solve for the inner circle, and we know the boundaries limit. Okay, we just want to find the limit of inner, how much water we can trap here. So like max water will be coming from adjacents. Okay, so we have 4 adjacents in all 4 direction. Okay, and we can trap how much water depends on the minimum of what these 4 adjacents allow to me. Okay, so in this particular example, how much water is getting trapped? So it's getting like 2132. So 1 unit of water will be trapped here, so it will become to 3 heights. We can't trap more water because it will be spilled out from here and here if I will trap more water here. From this cell we can see we can trap 2 unit of water here, so 3, it will become 3. 1 plus 2 is 3, and more water can't be added because it will be split from all 3 directions, like 3 3 3. This is the 3, and this is less than 3, so we can't trap any water here. Anything which will be filled here will be spilled out easily from this and this direction, both of the boundary directions. And this is the 2, so we can trap 1 unit of water here. So 1 plus 2 plus 1, we can trap 4 unit of water here. Okay, we have come up with two conditions, like there is no boundary, no water trapped in boundary, so we can't trap any water in boundary, and max water trapped will be based on the adjacent of this cell. Okay, we can call this a cell. Okay, so let me clear this. Okay, let's look at the example number 2 as well. Okay, so in example number 2 we have a height map of like 3 3 3 3. So I will draw a matrix here for this. let me draw a matrix 3 3 3 and I will draw matrix in horizontal mode this time. So I will explain that ordering doesn't matter. So 3 3 3 3 3 5 3 is here, then 3 2 2 2 and 3, and then 3 2 1 2 and 3, and then 3 2 2 2 3, and then at last 3 3 3 3 and 3. So this is like a nice bound, I can see. So this is our boundary and this is our inner circle. So I will mark only the inner circle. This is our inner circle in which we can trap the water. Outside boundary we can't trap any water. From the previous observations we can tell that how much water we can trap here. We can trap 1 unit of water here, plus 1 it will become 3. We can't trap more. Plus 1 will be 3, plus 1 plus 1 plus 1, and in the center we can trap 2 unit of water here, plus 2. Okay, that's the case. Okay, got it. So for that, from the first example we can, the intuition is coming that we can solve for each row individually, but from this that intuition is not coming, like we have to solve for the boundary and then inner boundary and then inner boundary, something like that. From outer boundary we can go in, something like that. I'm sort of thinking. Okay, let's do how to solve that. Okay, so let's ignore the outer boundary. Let's start from this. Can we solve for this row? If I solve for this row, and if I check for each before adding the water, I will check the 4 adjacent of that, 3 adjacent of that, because one row I am solving. For one column or one row, we can go column wise, we can go row wise. Okay, then I will look at here, I will solve for that, and I can look at here, I will solve for that. So if I individually solve for that, what the issue can come? Since I have solved column wise, there could be a problem that we can trap more water if I solve row wise. Okay. So which cell to consider first? The smallest cell, I think, making sense. If I found any smallest cell, I will fill it up until the equals of others. Okay, I will go with the smallest cell, I think. Then I can fill this. But how do I know what the smallest cell? That's the issue. Okay, let's continue with, I think second example is hallucinating us, because there's too much of symmetry and we can like trap in this symmetrical kind of thing. So like first example is better for explaining purpose. I think it will give us more clarity and intuition to solve rather than in second part. Okay, so let's try it again. Let me write it down. 1 4 3 1 3 2, then 3 2 1 3 2 4, and the third one is 2 3 3 2 3 1 2 3 1. Let me make 1. Okay, this is our grid, this is our inner circle. Apart from that, everything is boundary, and at the boundary, so let's take the boundary first. Okay, from the boundary, what we can see, that what is the smallest height here? 1, right? So let me change the color here. So this one is the smallest height here, this one is the smallest height here, this one is the smallest height here again. So let's take this for example. If I fill anything more than 1 in this inner circle, okay, like adjacent to this, it will be spilled out from here. Okay, so this is the lowest we have to consider, not the highest. This is the solid wall. You can see this is the solid wall. Okay, it will hold more much water, but since it's a solid wall, it can hold much water. We can't optimize for that. We can optimize for this. We have to optimize for this, that's the minimum wall we have built, 1 unit of wall. So we can trap only 1 unit of water adjacent to these cells. Okay, like not adjacent, because at the boundary we can't fill anything because it will be spilled out, but inside this. So if I trap like 2 units of water, example, let's forget it here, there is 0. If I trap 2 units of water here, then it will be spilled out from this. So we can trap only max of 1 unit of water here, since this is the minimum boundary wall. Okay, same case here. No, this is the boundary, complete boundary, like cornerstone, so that doesn't make any sense. Here also, like it's a cornerstone, doesn't make any sense. Okay, so can you do something about it? How much water will be trapped will be in this so this is our third observation, you can say. So we have made 2 observations. First, boundary we can't trap any water. Second observation, what we made, that we have to take the adjacent in the account table. Adjacent, we have to look at adjacent cells to figure out how much water we can trap at this current cell X. Okay, and the third observation, we found that from the boundary, if I go like layer by layer, so something like that, this is our grid, we can go inside one layer, then we can go inside one layer, then we go inside one layer. So layer by layer, if I go inside, I have to consider the lowest one at the boundary. Then this will become the boundary. I have to consider the lowest one here, then lowest one here, and then lowest one here, similar to that. Otherwise it will be like spilled out wala problem. Okay, got it. So let me remove some of the drawing. How how to approach this problem then? So after considering this third observation, which we have to do, go by the smallest one, like take the consideration by smallest one, it's become challenging and interesting here. That's why it's hard. Looks like hard. Anything extra they have given? Nothing. Okay. If I go, okay, let's take this as example, and let's consider that we go by this one. Okay, like can we think out of the box kind of thing here? Like, do we have to think reverse thinking? Something will be helpful here. In the reverse thinking model, what we will do, that instead of trapping the water, we will be removing the water, I think, right? In the trapping water, what we are doing, we are raining that, we are trapping some waters, filling up the gaps. In the reverse thinking, we can think of like we are removing some waters from this, like we are pouring some more water and spilling that out, like water will be spilled out outside. Okay, so these 3 will be like from this one, if I go inside, this is the easiest way. Like if I am a intruder, I will climb only the first one step here, and I can go directly inside. Something like that. I'm thinking in a completely wrong way. Okay. Hmm. Okay. If I, let's say, inside this, if I go, let's forget one year. I'm thinking about only this. Let's go with the second highest and third highest. Okay, this 4 is solid wall, so let's forget this. In the boundary we have one, we have some twos, we have some twos here, we have some twos here. These are the corner ones, so again leave it. That will not be helpful in going inside because it's diagonal. We have to check for adjacency. Okay, this 2 is looks great. I can go inside, but again the same problem. 1 3, yeah, 2, we are going inside, but it's 3. Okay, can we go from the 3 to inside, like something like that? From 4 to like inside 2 will become, from 3 we will go, we will find 1, something sort of that. If we do, okay, for let me change the color. For example, let's take this 3. Okay, and we check that, do we have to do anything about this? No. Do we have to do anything about this? No. Do we have anything here? No. We have anything here? Yes, 2. Okay, which is not in boundary. Okay, which is like inside the outer, exactly outer boundary. Okay, and do we have to do anything about it? Yes, we have to trap some water. Yes. How much water can be trapped here? That's the question. So cell of I comma j, how much water can be trapped? Okay, since I know that, okay, what's the adjacency above 4? What the adjacency? See the 3. What's the 3? And here 1. Okay, so it makes I can, like this one, from this one I can see that. Okay, let's forget about this one. From these 3 direction I can see I can make trap 3 unit of water, minus 2 is like 1, so we can, I can trap 1 unit of water here. Okay, so it will become 3. Okay, but if I solve for this, like I am unaware of this. Okay, I have to be aware of this one first. Let me change the color. Okay, if I have to be aware of this one first, I have to process this one first. If I process, let's say for example, somehow I am processing this one first. So what I will do, I will check 2, 3, 3, 3. So I can trap how much water? 2. So 1 plus 1, 2 unit of water I can, sorry my bad, 1 unit of water. 1 unit of water I can trap more here, it will become 2. It will become 2. And let's keep this 2 as it is, like we can trap more water in future. Okay, then we will go to this 2. Okay, everything is 2 2 2 now. These 3 are 2s. We can process any of them. Let's process this one. So anything, it will say like 4 3 3 3, so we can trap 3 unit of water here clearly, so it will become 2 plus 1, so 1 unit of water trapped here, it will become 3. Okay, we have changed it to 3. This 3, this is 3, this is 2, this is 2. So now we can process any of them. So let's process this first, because we have already processed this one. Okay, so this is 3 4 3 2. Okay, so how much water we can trap? We have to consider these three somehow, that we can trap 3 unit of water here. Otherwise, this 2 will be like hallucinating us. We can't trap any water here. Pretty difficult problem to solve, I think. Okay, it's time. Is there any hint? No hints given. Okay, some topics let's check. It's saying array. Yes, array. We have to deal it. BFS, breadth first search, and heap priority matrix. We have built a matrix. Heap means priority queue. Okay, heap will be used, you know that heap will be used for like keeping the minimum or keeping track of the keep tracking of the minimum or keep tracking of the maximum element in the scene array. Like till now what we have seen, we can see that if we can keep in a sorted way. Okay, do we need sorted? Yes, we need, because 1 then 2 then. Okay, that's why we are processing with the lowest element first, then 2 then 3s. Okay. So let's go with this. We are processing with 1, 2 and 3. Okay. So in heap we can add these elements. What's the BFS then? We have to search for column wise column, or row wise row, or like something else. BFS generally means that with graph, if you know that with graph we are doing BFS, and if we are doing priority queue, which is like heap, it's in the graph. Basically by the heap priority queue we are using the algorithm which is called BFS. We are solving layer by layer something. Okay, that's why it called BFS. If we are using DFS, depth first search, then we do not need to keep this priority queue, and we do not need to process layer by layer something. Okay, so if we need to use PQ, I don't think so BFS tag is more useful here. More useful tag is heap P priority Q1. So we have to give someone priority and then process them first, and then process the other one after that. Okay, I think let's traverse this one. If I want to traverse this, how I will go? Let me clear some of these my drawings. Okay. Okay, so if I need to traverse this, I will, let's say, keeping a heap here, P priority Q heap. I will keep a heap here. Okay, I will go with the boundary first. Okay, obviously. So I will take 2 heaps, min heap and max heap. Let's see which one is beneficial for us. So in min heap we will keep 1 1. Like there are 2 ones here, 3 ones here. So it will like 1 1 1, then 2 2 2, then 3 3, some 3s, and last में 4. In the max heap we start with the 4, then some 3s, then some 2s, and then 1s. Okay, this will be our heaps. Okay, in main heap way we will process this one first, example के लिए. Then we can check, is there anything above? No. Is there anything here? No. So this is obviously not a valid cell basically, but is there anything here? Yes. Is this 4? Okay, what to do about this? Nothing, it's already in heap. So this is like visited one. Okay, so if we have visited anything, we have to mark it visited, so we will keep it visited one also. I just remember that in BFS or DFS solutions we keep something like visited array, so this will help us keep track of what we have already seen, or what is the new. Okay, so we will new thing we will keep pushing in the heap. Okay, so this is already visited, this is already visited, so this one is done. Then we will process with this one will be done similarly. Then we will process for this one. This one is interesting, since from this one these 2 are visited but this is not visited, so we will push this 3 in the heap. I will push this with different color, let's say this 3. Okay, it will come here. heap, it will come here in makes heap after some threes. Okay, we are inserting from below in makes heap. Yes, okay. So this heap, and I will mark this cell as visited B. Okay, then I will process for twos. So all the twos will process. This corner twos will be useless. I think this corner two will be useless. This u2 will be useful, but all three array like side of this are visited, so this will be useless. There is no twos on boundary. Then you will process with threes. So let's progress with these three. So this is visited, this is visited. Above is nothing. This two will become important, so we will push this two inside this min heap. So it will come here. If I put it here, it makes heap, it will come here. Okay, I don't think so. Like min heap is making more sense because we are processing 1, then 2, then 3, and then 4. I can go like by 4 we start, then we can go 3, then 2, 1. Okay, let's first solve by min heap. If this is solving our problem, then I will go with this, otherwise we will do a dry run on mix heap. From the min heap perspective, we have a 3, and this 3 will be like pushing this 2. Okay, this will be like visited, then this 3 will come, this 3 will be pushed inside this, similar to this 3 will come in. Basically all the elements in between this will be pushed inside this. 2 2 2, there is 1, I think 1 2 1 3 3 2 1 3 2. Oh, I complete 2 1 3 2. That was the middle one, no? Yes, I completely destroyed because of my try run. So some 1 will be pushed here, some 2 will be pushed here. Okay, and after processing this one, so I will process this one now. Okay, to process this one, I need to look at what's the above, left, right, and down adjacency. These two adjacencies are boundaries. Okay, all thing is visited now, right? There is no concept of not visited. Okay, first time when I am adding from 3, I know that from 2, from 1 it's already processed. So from this one I know that it's already processed. Okay, so this is the minimum height. Oh, nice. Since I have already processed at the boundaries, and this is the minimum of boundary which we are processing currently, we can't go beyond that, but this is the minimum. Okay, so I found the minimum wall somewhere. Then to I just need minimum wall minus cell of I comma j. I will just minus that, and I will get the how much water we can trap. So I can trap like 1 minus 3, 2 unit of water here. Then I will process this. So 1 water here, 0 water here, and here is 2 now. So 1 unit of water here. Oh, I think I kind of get it. Let's quickly jump into the code. I think it's tricky one. Coding this will be like tricky something. Okay, let's take int equal to height map of size. What I'm typing here? About height map 0 dot size. Here constant is given that n is never 0, so that's not the key. We don't have to take care of that base case. Sorry. Otherwise we have to take care of that base case as well, where n is equal to 0. Okay, now we will keep a visited. Okay, so let's make it visit vector of vector. Okay, this will be like boolean vector named as visited. It will be n size in rows and in columns. I will keep another m size vector with default false. Okay, now I have a vector which is visited and default is false. And what to do now? I need a vector, I need a priority queue. Okay, so priority underscore queue. Okay, let me priority queue कैसा डिफाइन करते हैं. Let's std priority queue. It's correct. Okay, so what to keep in priority queue? We have to keep this. Okay, we have to keep cell location I comma j and the element, because if I keep the only element, which element I am processing I don't know, which cell I am currently at I don't know, so I have to keep the three information here. First information is cell का cell height map, and then cell का position x comma y, two coordinates of the cell. Okay, so can we do pair of inside that another pair, or should we do like vector of three elements? Let's keep vector of three elements here, which will like we will keep n. Okay, let me write here so we will be not confused after that. We will keep height x comma y, x coordinate y coordinate. Okay, name it pq. Okay, now we are ready for the processing. So for processing, what we will do, we will first go by the boundary. Okay, go by the boundary. So these boundaries we have to visit. We have 4 boundaries, 1, 2, 3 and 4. So we will visit all 4 boundaries and we will push each and everything in queue. Okay, this is like by default min heap. Let me it's min heap or max heap. Okay, for a min heap we have to add this greater int as well, the greater of vector as well. By default it's a max heap. Okay, is by default order is max heap. Okay, so to min heap I have to keep this vector of integer. How this greater thing will be solving like from vector? I don't think so it will be able to solve. Let's try the algorithm first. We can go by that after that. So 0 and a plus plus. Okay, we are going okay, we are going the row, so we will keep adding both the columns, like both of them. I generally use I for the row and j for the column. So let's go by first column and the last column first. Okay, so for traversing the column we are like going row by row, and we will keep j value as 0 or m minus 1. Okay, so j value will be here like 0 or m minus 1. Okay, so we will be marking them as visited and we will be pushing them visited of I comma 0 is true. We have visited this visited of I comma m minus 1 is true, and we will push both of them in pq. Okay, so we have to check. No, we don't have to check anything because we are traversing it first time. pq dot push. Okay, c plus priority q insert होता है इसमें. Insert, how to insert data, dot push होता है. Okay, dot push. We are pushing a vector. In the vector we have 3 elements. First is like height of them, height of I comma 0, okay, and I 0. Then we will push height of I comma m minus 1, I and m minus 1. We have pushed both of the columns. Now we will push both of the rows. So since we have pushed both of the columns, all four corners is already pushed, okay. We just have to go for int I barabar 1, j less than m minus 1, j plus plus. So we are traversing the columns, keeping the row same. So here I will be like 0 or I will be like n minus 1, correct? So we will do something similar. We will mark first visited of 0 comma j is true, and we will mark visited of n minus 1 comma j is true, and we will push both of them in our priority queue, similar to previous one. 0 comma j and n minus 1 comma j. Here will be like n minus 1, here will be like 0, ये हो जाएगा आपका j and this will become j. Okay, so we have pushed each and everything in our priority queue by the boundary perspective. Now what we will do, until the priority queue is empty, we will pop the first of the element. We will calculate the trapped water based on that, and we are keep summing that how much water is trapped. So int trapped water equal to 0. Let's make one variable. Okay, now I have trapped water is 0. I will go for this one. Okay, so while pq dot empty, pq dot not pq dot empty, we will do this. We go adjacency, we have to also find adjacent one, right? So for that we can find like two directions. Okay, so we can do the vector of int direction of row, and we have similar to direction of column. To find both direction, what we will do, we will do like keeping the row same, column is increased as 1, keeping the row same, column decreased by 1, keeping the column same and increase the row by 1, or keeping the column same, decrease the column by 1. So by looping into that 4 direction, I can find all the 4 direction and all the adjacent element to my current cell. Okay, or all the current adjacent cell I can find by going through these directions. Okay, so we can find vector of int, let's make it temporary int, pq dot top, pq dot pop. Okay, so now we have value as temp dot 0, and we have x coordinate as temp of 1, and we have y coordinate as temp of 2. So we have all three values with us. Now what we will do, we will go in all 4 directions. Like I am currently at cell I, correct? And before putting into this, have we calculated its height? Have we calculated? So let's first calculate this height. Okay, no, calculate its height first, and also add adjacent element to pq. ठीक है. So for finding adjacent adjacent, I will loop through this less than 4. So x and okay, if not visited, if valid, okay, because we can go out of bound as well. So if we have a valid I comma j, okay, which will be like x plus direction of row of valid is valid, okay, is valid, x plus direction of row of I, y plus direction of column of I, this is x comma y, okay, x comma y, so this is the good idea, x comma y comma n comma m, n comma m, we have to check if this is valid, and then not visited, so not visited. So let's make this new variable now. So new row will be x plus direction of row, and new column will be y plus direction of column of I. ठीक है. Now I will go with new row and new column n comma m, not visited, of new row comma new column. Okay, it's first validated. If it is not validated, it will go false. Okay, so the cell I'm going into, if that is the case, what I will do first, I will push it to the queue. One thing I have to do, okay, I have to push again this height map of 3 things. I have to push height map of new row comma new column, okay, new row is x and new column is y coordinate, okay. Okay, we have to keep, and we have to mark this as visited as well, okay. First mark it as visited of new row new col equal to true. ठीक है, we haven't calculated height yet, and we just have to make this one function as well, which is like is boolean is valid int x comma int y int n comma int m. If x is greater than equal 0 and x is less than n and y is greater than equal 0 and y is less than m, then it's true. Otherwise return false. If it is in the bound, it's valid, otherwise false. Okay, now the one main important part is remaining, using this trapped water, calculation of this trapped water inside this. Okay. Okay, so for this trapped water calculation, what I will do, let me return this My mind is completely like okay, got it. Our trapped water will be like trapped water plus how much trapped water we have. So this current cell, obviously, height map of new row comma new column, and this will be like reduced from the maximum wall we have seen till now. So what maximum we have seen till now? Minimum we have seen till now. So minimum we have seen till now is, I think, x comma y. Okay. So we are processing from cell I. We are going to all four directions. Some of the direction we have come from, so that will be excluded anyways. Okay. Should we like, when should we add this water? When I will be at 2, first I will push this 2, right? When I will pop this out, then only I will calculate this how many water I can trap, right? Or when I am pushing this inside that, should I calculate then? Anyways, matlab, I am pushing all four like visited here, marking it visited and pushing all four of them. Should I mark them as calculated now? That's a good question. Or should I calculated this? Okay, I got it, I think. So whenever we are pushing this new cell, we will trap the water. Okay, something like so. If the height of current one, this is the height, if it is less than, like, whenever I am going to someone, I have visited the boundary, I am going inside. If I found that this is the lower, I come up with the second example, like this is a 3333 boundary. If I go inside this, so this is a smaller one. If it is smaller one, I can directly calculate the how much water I have trapped, because 3 unit of water from this boundary I can see. So maximum 3 minus whatever the cell height I can trap. So if this is like the new cell height is smaller than the boundary height is will be calculated as height map of x comma y, from which we are started with. Then though I can do like trap water plus equal how much trap will be height map of x comma y minus this. I think this should work. Let's run this. Errors is part of the life. Okay, I got it. So there is nothing like, oh, where I can, there is nothing like greater than vector of int. Okay, let's Google it. Greater vector. Okay, how to, how is this one? I want to keep min heap by first element of vector in C++ line, but the above line giving error, please something like, because of proprietary queue template requires the type of value type. Okay, same as a value type specified in the template. In your case, vector of int is a value type, vector array is a underlying container which is default when not specified. To create a mini heap order, first element you need to provide a custom comparator. Okay, we have to create a custom comparator that will define the greater than. Okay, so this comparator we have to define. So we will do vector of int, we will do vector of int again, vector of int, and then compare vectors. These two vectors have to compare, something like this. Okay, so let me create this struct. The same class, compare vectors operator. Okay, remove this std1. Okay, constant of second vector for mean if a is greater than b, if a0 is greater than b0, correct? So this is mean heap we have created, and here also, and here I also have to give vector of and we have to provide a custom comparator for the comparison. Compare vectors. I think this should compile at least now. It's compiled. Now it's giving the wrong answer. Okay, let's check what temp here is I'm getting first, so I can be sure that we are using the min heap. Okay, see out value. It's submitted. Okay, 12 out of 42 test cases passed also. I don't know why. Okay, it's we are creating min heap. It's clearly stating that 1 1, then 2 2, then 3s are popping out, then 2 3s, then 1s inside that, and then 4s. Okay, got it. So it's saying output is 3, then expected output is 4. Okay, got it. Something is off here. We have to fix some small thing. We are almost there, I think. It's pretty long video. The most longest video I have created in this channel till now. Here we are taking value temp0, which is same as x comma y, obviously. So it will be like my value minus this. Doesn't make any difference, but I don't think so. What's the issue here? Oh, some characters there. Okay, let's try this one. Oh, okay, I got it. Here we have to push the maximum height of these both, right? If I am, yes, so we have to push the wall height here, correct? Yeah, max of value comma what the wall height comma this height. I think we have to push that value inside, otherwise so it will be like, yeah, got it. So I hope you understand this, because in the previous trapping rainwater one problem also, we are taking the maximum of left max and right max. We are keeping two variables. Similarly here we have to keep the maximum boundary height we have seen till now, and because there's the maximum boundary height, from there we will keep finding the how much water is trapped in the next iterations. I think let's submit it. Yeah, now it's solved. I hope you found this Interesting. This is a very difficult and challenging problem. Come up with the intuition, and solving this will be like very challenging in an interview. But if you have solved it once, you maybe come up with the solution in the interview as well. I hope this helps. Bye.